Hello and welcome to all students. This is SYBSc class, semester 4, paper number 1, calculus 4, unit number 3, beta and gamma function. And in this lecture we are going to study about properties of beta function. In the previous lecture we studied some properties of beta function. Now in the previous lecture we proved one property of a beta function, and that property is beta mn is equal to integration is equal to 2 times integration over 0 to pi by 2 sine raised to the power 2m minus 1 theta into cos raised to the power 2n minus 1 theta and d theta. Okay, so we have proved this property of the beta function. So in this beta function, if I substitute m is equal to p plus 1 upon 2 and n is equal to q plus 1 upon 2, then what we get is we get the value of integration over 0 to pi by 2 sine raised to the power p theta into cos raised to the power q theta is equal to q theta d theta is equal to 1/2 into beta p plus 1 by 2 comma q plus 1 by 2. Okay, so this is one more result which we proved from this property of the beta function. So let us go to the third property of the beta function. That third property says that beta mn is equal to integration over 0 to infinity x raised to the power m minus 1 divided by 1 plus x raised to the power m plus n dx. Okay, so can we prove this property of the beta function by using definition? Okay, so let us try to prove this property and write down proof. We know the definition of a beta function. Beta mn is equal to integration over 0 to 1 x raised to the power m minus 1 into 1 minus x raised to the power n minus 1 dx. Okay, now we use this substitution to prove this property of the beta function. We use substitution. So instead of x we put t upon 1 plus t upon 1 plus t. Therefore dx will be dt upon 1 plus t its square. Okay, 1 plus t square. So due to this substitution we have a new variable, and the limits of that new variable we write here. Okay, limits of new variable. So our original variable is x and its limits are from 0 to 1, and now new variable is t, and its limits are, if I put x equal to 0, then the value of t will be 0, and from this equation we can calculate the limits. And if I put x is equal to 1, in this case the value of t will be infinity. Now it becomes limits of new variable is from 0 to infinity. Okay, so let us use this substitution and see what we get. So left hand side is beta mn, so we are making substitution in this integration, and the integration is from 0 to infinity, and instead of x I will write t divided by 1 plus t raised to the power m minus 1 into 1 minus t upon 1 plus t raised to the power n minus 1, and into dx is dt upon 1 plus t its square. Okay, so try to simplify this integrand, and it is equal to now if we simplify this integrand, finally we will get integration from 0 to infinity, and we get that t raised to the power m minus 1 divided by 1 plus t raised to the power m plus n dt. Okay, so this is beta m n, and the this is beta mn. So this integration is in terms of variable t. The same integration we can write in terms of variable x. So change in variable, there will be no change in the value of integration. So it is equal to integration over 0 to infinity, and x raised to the power m minus 1 whole divided by 1 plus x raised to the power m plus n dx. Okay, so this is the proof of third property of beta integration. Okay, now let us try to prove the next result, means fourth result, and that fourth result is nothing but the relation between beta and gamma function. Okay, the relation between, so let us write here relation between beta and gamma function. Relation between beta and gamma function. Okay, so that relation is, we state first relation here, beta m n is equal to gamma m into gamma n whole divided by gamma m plus n. Okay, so we keep in mind this relation while solving the examples. We will use this relation. Okay, now let us go to the fifth property of beta function, or we prove that this gamma 1/2 is equal to square root pi by using the property of beta function. Okay, so let us see how to prove. So right here, proof. Write proof. We know the property of beta function, and and that property is integration from 0 to pi by 2 sin raised to p theta into cos raised to q theta d theta is equal to 1/2 into beta p plus 1 by 2 comma q plus 1 by 2. Okay, so this is the property of beta function, and in this property we use the substitution, use p is equal to q is equal to 0, means we put values of p and q 0. So on the left hand side what we get is integration over 0 to pi by 2. So if I put p and q 0, the value of sin raised to p theta cos raised to q theta is 1, and therefore left hand side is integration over 0 to pi by 2 d theta. It is equal to 1/2 into beta. If I put p and q 0, it is beta 1/2 comma 1/2, beta 1/2 comma 1/2, and by the above property, fourth property of beta function, the relation between beta function and gamma function, and that relation is gamma half into gamma half whole divided by gamma half plus half. Okay, it is equal to 1/2 into gamma half and its square and whole divided by gamma 1, and gamma 1 is 1. Okay, since gamma 1 is equal to 1. Okay, so try to solve this left hand side integration. So up to now what we have is integration. Therefore we have integration 0 to pi by 2 d theta is equal to 1/2 into gamma half raised to 2, and the integration is theta, and lower limit is 0, upper limit is pi by 2, right hand side is 1/2 into gamma half its square, and the value is pi by 2 is equal to 1/2 into gamma into gamma half its square. Okay, 2 will get cancelled. On the left hand side it is only pi is left, right? On the right hand side it is gamma half square, taking square root, it is square root of pi, it is equal to right hand side is gamma half, and thus we proved the fifth property of gamma function. So gamma half is root pi, gamma half is root pi. Okay, so there is one more property of the gamma function, and that property is the sixth property. Okay, sixth property of gamma function, and that property is known as Legendre's duplication formula. Legendre's duplication formula. Legendre's duplication formula, and that Legendre's duplication formula is gamma m into gamma m plus 1/2, and it is equal to square root pi divided by 2 raised to the power 2m minus 1 into gamma 2m. Okay, so this formula is known as Legendre's duplication formula. Okay, so we use this formula or this property without proof. Okay, so let us stop our lecture. This is end of this lecture, and thank you for paying attention. Thank you very much.